In this video, I'm going to focus on different types of mirrors and the formation of an image in a plane mirror. Mirrors are reflective surfaces. It means the light can't pass through them, but bounce off their surfaces. For example, if I have a flat reflective surface and I shine a light onto it, as you can see, we show the light with an arrow and we name it the ray model of light. Then the light reflects off the mirror. The shone light is called the incident ray, and the reflected light is called the reflected ray. So let's name them here: incident ray and reflected ray. If we draw a line perpendicular to the mirror at the point of incidence, here, the part that incident ray hit the mirror, we name it the point of incidence. Point of incidence. Okay. And if we draw a line perpendicular to the mirror at the point of incidence, this line is called normal. That we show it with blue line. And as you can see, the angle that incident ray makes with normal, this angle, is equal to the angle that reflected ray makes with normal. It means this angle. If I name this one theta r, and if I name this one theta I, as you can see, theta I is equal to theta r. We name this law the law of reflection. It means the angle of incidence is always equal to the angle of reflection. Okay, right now let's look at different types of mirror. There are three types of mirrors: plane mirrors, or we can name them flat mirrors, and curved mirrors, that they include concave mirrors and convex mirrors. A plane mirror is a flat reflective surface. But if we want to learn about curved mirror, imagine that we have a glass sphere as I've shown here, and we cut it into two parts. So if we cut it from here at the center, so I start cutting that from here. So I have two parts. And then if we paint the outer surface, so I start painting the outer surface of the mirror, like here, then the inner surface becomes the reflective surface. This kind of mirror are called concave mirror. If we paint the inner surface, like here, if I paint this part, the inner surface of the mirror, then the outer surface becomes the reflective surface. This kind of mirror called convex mirror. So this one is concave and this one is convex mirror. The center of a sphere is the center of mirror. So if you look at here is the center of a sphere. See, this center also is the center of mirror. The line from the pole of the mirror means this part, and I show it with P. The line from the pole of mirror and its center, and if I name this one is center, that is C, is called the principal axis. So this line is the principal axis. Focal point is halfway between the mirror and the center of the curvature. So if here is the center, this point, and this length, if we divide it by 2, the point at the middle, we name it, we show it with F, and we name it focal point. The distance between the focal point and the mirror is called the focal length. So from pole to focal point is focal length, and it's equal to 1/2 of the radius of the curvature. So if the radius of this sphere is R, definitely is R, so it means from pole to focal point is R divided by 2. Okay. If you shine lights which are parallel to the principal axis of a concave mirror, like this, they're reflected off mirror in a way that they gather at the focal point. The reflected ray, as you see, the light is parallel and is reflected back somehow that is passed through focal point. And the same things happen for this. So this type of mirror is also called converging mirror. Right now, if we shine light which are parallel to the principal axis of a convex mirror, they're reflected off the mirror in a way that they seem they come from the focal point. So they're reflected back. And if we continue these reflected rays at the back of the mirror, they just hit each other, they cross each other at the point that actually is the focal point of convex mirror. Because the reflected rays, as you can see, they are diverging from each other. This type of mirror also called diverging mirror. Right now, let's look at the formation of image in a plane mirror. Let's see, we have a plane mirror here. When you want to find the image in a plane mirror, the first step is to draw a plane mirror. After that, we draw the principal axis, and then one arrow as our object. And then we need to shine light from the tip of the object or arrow. So as you can see, this light is parallel to the mirror, and we know this is not curved mirror. So remember the law of reflection. If this one is incident ray, definitely the normal also is on top of that. So it means the angle between incident ray and normal is 0. So the angle of reflected ray and normal should be also equal to 0. So it means it's reflected back on itself. For finding image, we need 2 incident ray, okay? And second incident ray, just we shine a light, the pole of the mirror, and you see the normal is this line, and so the angle of incident is theta I. So we need to draw reflected rays somehow that the angle of reflection is equal to the angle of incidence. So this is the reflected ray. The image of an object, the image that we can see is the place that 2 reflected rays cross each other. But as you can see here, 2 reflected rays are diverging. So it's obvious, even if I continue both of them at this side of mirror, they never cross each other. So I can't see one image in front of the mirror. But if I continue this reflected ray at the back of the mirror, they might be able to cross each other. Let's see. Okay. And see. So as you can see, the reflected ray can cross each other at the back of the mirror. So this point that they cross each other actually is the image of tip of this object or tip of this arrow. but you can see this image is at the back of the mirror, so we can't have it on screen. The images that form at the back of the mirror, we name them virtual images. So it's virtual image. And as you can see, it's the same size as our object. So it's same size. And it's same distance from the mirror, same distance. And also you can see the image is upright. Okay, so the property of the image in a plane mirror always is this 4, and always the reflected lights are diverging.